2.5, and 2.5 squared gives us a value of 6.25. Okay. We have 3.5 minus 5 gives us minus 1.5. Minus 1.5 squared is going to be 2.25. We have 3.5 minus 2 gives us 1.5, and 1.5 squared is 2.25. We have 6 minus 9 gives us minus 3. Minus 3 squared gives us 9. And then we have 9 minus 7 gives us 2. 2 squared gives us 4. So they're the squared differences, and what we need to calculate now is we need to calculate the summation of them. So what we're going to do is we're going to sum up all these values here. So we have 0.25 plus 1 plus 2.25 plus 2.25 plus 0 plus 6.25 plus 2.25 plus 2.25 plus 9 plus 4 gives us a summation of 29.5. So 29.5. This is the sum of the d squared values, okay, of the differences. And now we're in a position to calculate our Spearman rank order correlation. So RS is simply equal to 1 minus 6 times this squared value here, which is the sum of the d squareds, which is 29.5, divided by 10 times 100 minus 1, because 10 squared is 100. Okay. So RS is equal to 1 minus, let's do the numerator here, so it's 6 times 6 times 29.5 gives us a value of 177, and that needs to be divided by, well, 100 minus 1 is 99, multiplied by 10 is 990. So now we have RS is equal to 1 minus 177 divided by 990 gives us a value of, it's about 0.1, let's say to 2 decimals, it's 0.18, and then we end up with RS in this case here is 0.82. Okay? So the correlation coefficient is, and the Spearman rank order correlation coefficient in this particular case is 0.82. Now, just in relation to an interpretation of that particular value, and I suppose if we follow Cohen's, let's say Cohen's, I suppose, let's say, scale in relation to interpreting the magnitude of these correlation coefficients. Well, just say, let's say, from an interpretation perspective, we can actually interpret them particular values on the scale of, let's say, if it's, what I'll do is I'll just draw a line out like this. Okay, a line. I have 0 here. I have plus 1 here. I have minus 1 here. Let's say I have 0.5 here. 0.5. I have 0.3 here. Minus 0.3, minus 0.5. If it's equal to minus 1 or plus 1, it's said to be perfect. Perfect. There's a perfect association, perfect correlation. Perfect. Okay. If it's less than plus 1 and strictly greater than 0.5, we say that there is a strong or large, there's a strong or large correlation, and similarly over here, if it's greater than that and less than this, it's going to be strong negative. Okay? If it's less than 0.5 and strictly bigger than, less than 0.5 and bigger than 0.3, we say there's a moderate or medium. Okay, there's a moderate or medium. Okay, medium correlation. If it's, I suppose, if it's, we could actually put in 0.1 here and minus 0.1 here. Similarly over here, if it's less than that and greater than minus 0.3, we have it's moderate. It's moderate. Right? And then inside here, we say that it's weak. Okay, inside here it's weak, and in this little region here, we say that there's none. Okay, so inside there and there, it's weak or very weak. Okay, and you can see that our correlation coefficient is 0.82, and 0.82 is in here. It's a positive value, so there's a positive, strong association between a respondent's score on the survey, okay, and how much money they spend typically for lunch, if that makes sense. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this short video dealing with the Spearman rank order correlation coefficient, I hope that this was in some way intuitive, and more importantly, I hope that was helpful for you. And thanks for watching. Okay, bye bye.